to help you get back into the zone, I suppose, for writing code in Python. I've got a couple of exercises for you to do to refresh your memory of for loop syntax and working with lists in Python. So I've put both of those exercises on the screen here. The first one is this understanding loops exercise, which asks you, given the following loop, and here's the code, how many times is the body of the loop, that's the part that's indented here, how many times is that body of the loop executed? You've got options 3, 4, 5, or 6 times. And then the second exercise asks you to write another loop that will calculate and output the sum of the elements in a provided list of numbers. So let's do that, calculates and prints out. Let's see. All right. So I'm going to give you 11 minutes to do those 2 exercises. Feel free to ask questions in the chat or to unmute and ask me over the microphone, and then we'll move on to, well, I'll talk through the solutions and then we'll move on to the next section of the lesson. Just to say, I shouldn't have put in and prints out into that second exercise description. Write a loop that calculates the sum of the elements. And we'll talk about how you would print it out when we go through the solution. right, so let's talk through these two exercises. First one was the relatively shorter of the two, I suppose. It asked you, given this loop, word equals oxygen for letter in word, print letter, how many times will the body of the loop be executed? And you've got options 3, 4, 5, or 6 times. Would anyone like to type into the chat what they think the answer is? And then it says 6 times. Anybody else want to have a guess? Or tell me what answer they found? So let's take a look. I'll type this out quickly. So word equals oxygen for letter in word, colon, enter, print, letter. Oops, if I spell it correctly, there we go. So what this loop is going to do is it's going to print out this letter, the value associated with this letter variable each time we run through the loop. And this variable that's defined in this part of the for statement is referred to as the loop variable. So that the value of that loop variable is going to be printed out each time that we loop through. And then we're going to do that for everything in Word. Now, Word is a string, and we learned yesterday by looking at how we could slice strings and how we could split them up and things like that. The strings are treated by Python as sequences of characters. And so what this loop's going to do is it's going to run through each of the characters in this string variable called word one at a time. So it'll start with O, then X, then Y, then G, then E, then N. And so the correct answer is 6, as a few of you have now written into the chat. Let's run this to prove it. So we get each of the letters printed out individually, one after the other, through the length of the word until we get to the end, and then the loop stops. All right, so what about this summing a list? What about this summing a list exercise? It asked you to write a loop that calculates the sum of elements in a list by adding each element and printing the final value. So there we go. We can use this. We've been given in the exercise a kind of test list. So we'll paste that in here. We know that the answer that we want to get is 562. So I think that the wording of this exercise is a little bit misleading. And I probably made it even more confusing by trying to edit it on the fly beforehand. Because you can't, well, you can write a loop that calculates the sum, but you can't print out the sum in the loop unless you print it out every time as you're building it up. So I'm going to show you what I mean. So to start with, to be able to perform this kind of summation operation with the for loop like this, we need to start out by what I mean. So let's write the part that we might think of first, which is for number in, say, test list here. Total equals total plus number. And by doing this, each time we loop through, we'll be increasing this total by whatever the number is. But the problem is that we haven't defined this variable called total yet. So if I try to run this now, what we'll get is an error message, and this is another one of those categories of error called name error. You'll see these, in my experience at least, you see these name errors most frequently when we mistype the name of a variable, and so Python looks for a name that doesn't exist because we've mistyped the name of one that does exist. But in this case, we're trying to use a variable that hasn't been defined yet, and so we get this error: name total is not defined. So what we need to do is what's usually referred to as initialize this total variable, and we should initialize it with the value 0, right? So on the first loop through, on the first iteration through the loop, total is 0, and then we add the first number to the total. So we could put it here, right? But the problem with putting it here in the loop is that each time that we run through the next iteration of the loop, total is going to be set back to 0. And so what we'll end up with, if we run this, is a value of 36 for total, because each time before that, whatever we create here is just going to be overwritten at the start of the next loop to be 0. Let me show you what I mean. So if we print total here, then what we see is, let's go through this. So for the first iteration, total gets set to 0, then total becomes 0 plus 124, because that's our number on the first iteration, and we print that out. Then we go through the next iteration, number becomes 402, but total gets set back to 0. And so then total equals total plus number gives us 402 again, and so on. So actually what we want to do is not have total equals 0 here, but instead put it up here before we start the loop. And then we get this 124, 526, 562. 562 is the magic number that we were hoping to get, right? That's the sum total of these three numbers. But the problem, I suppose, so to speak, is that we're getting this number, this total output as it's being built up. And what we really want is only the total once the loop is finished. And so to get that, we need to remove the indentation before the print total line, so that now we set total to 0. We run through this loop, summing up the values. And then once the loop is finished, this print total line will get run, and we'll see only 562. And I think that the wording of the exercise is a little misleading, because it says write a loop that calculates the sum of elements in a list by adding each element and printing the final value. And you can't really write a loop that prints only the final value. So instead, you print the final value after the loop is finished, like this. And then the last thing that I want to tell you is if you find that you're very often writing this kind of thing, so something equals that same thing plus something else, or minus something else, or multiplied by something else, or whatever, then there's a shorthand way of writing this kind of operation. And that's, instead of putting total equals total plus number, we put total plus equals number. And this plus equals is a incrementation operation. So what this means is add the thing on the right hand side to the thing on the left hand side, and assign the result to the thing on the left hand side. So it's like add plus assign together. And we can run that and see the final result. Before I move on to the next section, what questions do you have about these two exercises, or anything to do with this looping that we've just been talking about now?
Toby, I've got a question on the counter that we defined. Does it have to be number or letter? Can I not use X, N, or whatever?
Yeah, you can use whatever you like for the names of the loop variables here. So like this can be Toby, for example. Then you would only need to make sure that you adjust the body of the loop to match up with the name that you're giving the loop variable up here. The result is still the same. Does that answer your question?
Yes, it does. It does. I thought maybe number and letter possibly specific for
no. So The
just counter.
variable names are kind of arbitrary. You can choose them, and they don't have, what you call a variable has no bearing on the value that it contains at all. But the reason that we use like letter and number here is because it is a good idea to try to use descriptive names of variables that give whoever's reading the program some correct impression of what value that variable is likely to be holding, because it makes your program much more readable. I say this as if you're writing programs that lots of other people are going to be looking at, but honestly, it's also really important just for you in the future. I find that if I write a program and then I go away and do something else for 3 weeks, and I come back to that program, I probably don't really remember exactly what I was doing on each line. And if you make your variable names kind of descriptive like this, so that they give people an impression right away of what kinds of values they're likely to store, it makes your program as a whole much more easy to understand, I suppose, and to interpret like what it's doing as a human reading through it. This is often referred to as writing what's called self-documenting code. So code that is written in such a way that by only reading lines of code, you can already get an idea of what's actually happening in each place in the program. Does that make sense?
Yes, it does. Thank you so much.
Okay, cool. Thanks. As well as writing code with descriptive variable names like this, it's also a really good idea to remember to use those comment lines that I remember I think maybe Kautar told you about yesterday. I can't remember who told you about the comment lines, but anyway, you can add comments to your code by print out the summed total created by the loop, for example. So anytime in a line of code when you put this hash symbol, then everything to the right of that hash symbol will be treated as a comment. And so this doesn't get interpreted by the Python program itself. It's only there for humans to read. So you can use these to annotate your programs to further kind of document what's happening on each line as a reminder to you in the future, but also to your colleagues and collaborators if they're going to be using the program as well. One final kind of trick I'm going to mention with commenting is that when you're writing programs, it can be really helpful to be able to very quickly activate and deactivate whole lines or blocks of code while you're kind of testing things out or trying to isolate where a problem is in the program that you're writing. And one thing that can be very helpful with doing that is adding these hash symbols at the beginnings of lines. If you do this, then this is called commenting out lines of code, and it kind of, because the hash symbol tells Python that what comes next is comment, then Python doesn't try to run the code there anymore because these lines have been commented out, and so you can kind of deactivate blocks of code. So when I run this now, it'll still print 0 because total is 0 and the loop doesn't get run. And then when we're ready, we can remove those comment symbols to reactivate the line code again. And there is usually, in most interactive environments, at least where you're working with Python, there's usually like a keyboard shortcut to introduce those comments. I think in Jupyter, it's Control/, or I'm working on a Mac, so in my case, it's Command/. So I can press that and it toggles commenting on and off the line. And so one very common pattern when you're what's called debugging your programs, when you're trying to isolate where a problem is occurring, is there are more sophisticated ways of doing this, but an approach that I really recommend that you take right from the beginning is you make liberal use of these print statements. So print test list here, for example, to give you a lot more kind of feedback about what value variables contain at different points in your code. It can really help you kind of trace what's actually going on from line to line, how the different lines of code are affecting the values of the variables in your environment. You include all of these print statements, but then of course, what happens, especially when you've started to write like 50 lines of code or something, if you've got all of these print statements in as well, then the output that you get from your program gets noisier and noisier. This is the result we're actually interested in, right? 562. We've also got these two lines of what I usually think of as debugging output that tell me what's happening line by line in my code. And when you then want to kind of reduce that noise, but you don't want to have to delete each of these lines and then, in the future, maybe write them back in again, then using this keyboard shortcut to comment out the line very quickly allows me to deactivate that kind of those debugging print statements and then reactivate them again in the future if I want to use them again. So a couple of tips there for how to use comments as a way to kind of program more effectively, I suppose. All right, please give me 2 minutes to get the workbook set up for the next section, and then I'll get started again. All right, so I've been promising you for a little while, since like halfway through yesterday, that what we were building up to was return to this kind of data visualization and how to work with a larger set of the kinds of data files that Kautar was looking at with you for this kind of information data. But before we could get back to that point, we had to spend some time talking about lists and about loops, and it's going to become, I hope, clear in the next half hour why it was necessary for us to spend all that time talking about those things. Because now we're going to talk about how to apply those things and the stuff that you learned before with NumPy and so on to multiple data files all at once. To do that, the first thing we need to do is access these multiple data files in our Python program. And to help us do that, we're going to import another new module into our Python program. And this one's got another weird name like NumPy. This one's called glob. And what glob does is it helps us match like multiple names of files in our system. So the first code that I'd like you to write and run says import glob. We'll run that, and we don't get any output, which is a good sign because that means that nothing's gone wrong. This should work for everybody, regardless of whether because there's nothing that needed to be installed for using glob. Glob is a module in what's referred to as Python's standard library. So this is the standard library is a collection of kind of additional modules that provide additional functionality to your programs, but that come included as standard with Python. Then they still need to be loaded in, they still need to be imported when you want to use them, but they're installed at the same time as Python is installed. So if you've got Python on your system, then you should have glob, for example, on your system. The same was true of the time library that I think you were using yesterday or the day before as well. Okay, so we've imported glob. And then what we can use glob for is the glob module contains a function that perhaps confusingly is also called glob. And let's have a look at what that does by putting a question mark afterwards, pressing enter. So the signature, if you remember, is kind of a usage statement. It tells you how to actually use this function. It says glob.glob, path name, it's a star here, and then recursive equals false. So that means this equals false means that the default value for recursive is false. And then it says what this does is it returns a list of paths matching the path name pattern. The pattern may contain simple shell-style wildcards. However, file names starting with a dot are special cases that are not matched by star and question mark patterns. I don't know if you talked about this in the shell lesson or not, but file names that start with a dot in Unix environments, those are hidden files. So the way that you define that a file should be hidden from the kind of normal view is by starting its name with a dot. And that will mean that then when you kind of list the contents of a folder, for example, then the standard behavior is for any file names that start with a dot to not be included in that listing, and you need to kind of explicitly say you want to include hidden files for those things to show up. And so what this is saying is that glob will not match files that start with a dot using these two wildcards, so star and question mark. We'll talk about star and question mark soon. If recursive is true, the pattern ** will match any files and 0 or more directories and subdirectories. So this is how you can match the files that include the dot at the beginning of their name, for example. Anyway, we don't really need to worry about any files starting with a dot in this case, but as we're reading through the documentation, I thought it was necessary to explain it to you. But what this means is we can run glob.glob and then provide a path name in the parentheses afterwards, like this. It needs to be a string, so let's see if we've got anything in the data folder here. Okay, so we've got a data folder. I need to learn a little bit more about where I'm currently working in my file system in this Jupyter notebook. And to do that, I can run, if you think back to the first part of this workshop where you were learning about shell and the shell commands, you can run a lot of shell commands that you learned about at the start of this workshop directly from within a Jupyter notebook like this by starting your code cell with an exclamation mark like that. And then, so for example, I can type !ls, and this is going to be run not but as a shell command instead. And if you think back to the beginning of the workshop where you learned that the ls command lists the contents of a directory, and in this case, because I'm only running ls, it's going to list the contents of my current directory. So if I run this, then we see I've got 3 files that end .ipynb, and those are these 3 Jupyter notebooks that I've been working with so far while I've been teaching. And then I've got this folder here called data. To give another example, we can also run pwd as a shell command by putting an exclamation mark at the beginning of it. And you hopefully remember that what pwd does is it prints the working directory. It tells you if you're currently working. This is kind of a long path, but this tells me that I'm in the users folder from the root. Then in the Hodges user documents, a folder called software carpentry, a folder in there called workshops, a folder in there for this specific workshop, and then a folder in there called SWC Python. So a pretty long path there. And I can run exclamation mark ls and then data to see what's in that data folder. And if we look in the data folder, we see that there's a bunch of CSV files that are called inflammation minus and then 0102 right the way through to 12. And then there are these three that are called small 01, 02, and 03 as well. And what we are going to want to do is perform the same operation in a loop through all of these files that begin inflammation dash. And that's where this glob comes in, because what glob allows us to do is create a list of file names that match a particular pattern. And so we can say data, oh, this needs to be in a string, sorry. So put some quote marks at the beginning and at the end. And it's going to be inflammation, sorry, data slash inflammation and minus, then a asterisk symbol, star character matches 0 or more characters before CSV. So what this is going to do is it's going to match anything that starts inflammation and ends .csv inside this data folder. So let's run that and prove that it works. And sure enough, what we get out is this. We know it's a list because it starts with a square bracket and ends with a square bracket, and it's got commas between each of the entries. And then inside this list, we're giving us the name of each of the inflammation data files that are contained in that data folder. And if we wanted to be more specific, we could use the question mark wildcard instead. So where I said that the asterisk symbol matches 0 or more of any character at all, what question mark does is it matches any character, but only a single character. So exactly one character in that position. And so, for example, we could put inflammation -0 question mark, and this would match anything that starts inflammation -0, and then any character here. So let's run that, and we see here that we only get the file names that include a 0, and we don't get inflammation 10, 11, and 12 in this case. And so we could also put question mark to match any 2 characters in this position and get all of the file names as well. In this case, the double question mark here, that approach is directly equivalent to using the asterisk, because we know that all of our file names only have 2 numbers here. But if you were working with a larger number of files and some of them had 3 numbers here and some of them only had 1 number here or whatever, then the asterisk would be what you would need to use, because you couldn't use question marks to represent the same kind of pattern that you're looking for. All right, so let's have a look at the things that have come up in the chat. All right, so the LS approach isn't working for you, Polites. I guess that this is because you're working on a Windows system and there's something about how Jupyter is set up so that it can't run Unix commands on the Windows system. Please, if you're not working on Windows, then let me know in the chat, but I would guess that that's what's going on there. And Isaac says not getting any output from glob data. So this will depend on where you are working. Right, thanks, Polite. This will depend on where you're working in your file system relative to where you saved those data files at the beginning of this Python session. So I guess the easiest way to find that out is if you click on this little folder symbol to the left-hand side in your Jupyter environment, then you should see listed on the left here files and folders in your current location. I've saved the data folder where I'm also saving my notebooks, but I guess in your case, you don't have a data folder there. If you see the information files directly listed there, then you can get the same kind of result by doing glob.glob and then inflammation-star.csv. The important thing is that you need to adjust the path that you're providing in this string to lead to the location where you've saved those information data files. And so it'll vary a little bit depending on where they are relative to where your Jupyter notebooks are being saved.
Hi, Toby.
Hi.
Yeah, so those files are on the desktop, and that's where it is. But do I need to kind of find my way to the desktop before I issue that code, or I can just?
I think it depends where your do you know where your Jupyter notebooks are saved?
Yes, it's saved on my drive C.
Just on the root of your C drive, or are they in a folder there?
Okay.
All right, cool. So Polite, in your case, it looks like you're already in the location where your inflammation files are stored. So you should be able to run this version of the function, so without the data slash at the beginning, and you should see this. Well, you should see almost this output, but you won't have the data slash at the beginning of it. You'll just have the names of the CSV files if you run this. So Isaac, back to you. Yeah, so the easiest thing for you to do will probably be to move using your file explorer, move the inflammation CSV files to the place where your notebooks are being saved, so that then they're accessible.
That's the Jupyter notebook.
Without type out a long sorry, can you say that again? You broke up a little bit.
Okay, you mean I should move it to where the Jupyter notebook is
exactly.
installed or saved?
Yeah, you should move it to where this the notebook file that you're currently working with, this .ipynb file, wherever that is saved on your system, move all of those inflammation CSV files to the same place.
Okay, all right.
And then once you've done that, you should be able to run this this function call in this cell to get a list output that looks, well, similar to this, but without the data slash at the beginning of it.
Give it a try. Thanks.
No problem. I'll give you a moment to try to do that while I drink some water.
Hey, Toby.
Hi, what's up? How's it
Yes.
going?
So sorry to be dragging everyone back. So it's saved
That's
in my
okay.
programs folder. So do you mean I need to move the data in the Python folder, which we originally put on the desktop, to that where Anaconda is?
No, so you shouldn't be moving it to where the Anaconda program is installed. But when you started working in this Jupyter environment, you will have created when you launched one of these notebooks, that program will have created one of these .ipynb files wherever
Okay.
wherever you were when you launched the program. I'm afraid that will depend on where you were when you ran the either how it's set up as default on your system, or where you were on the where you were working in the terminal when you ran the Jupyter Lab command.
Okay.
So the easiest way usually to find that out is to look at what's listed in this file explorer thing here. You could also try the PWD approach to see where that tells you you're currently working. But again, if you're on Windows, by the looks of it, that might not actually work for you. So I'm afraid it's hard for me to tell you exactly what to do, because I don't know where the various locations are on your system and so on. You could try sharing your screen, and we could try to work through it together if you think that would help.
Okay.
I'm just going to polite looking at the screen grab that you put into the chat. You should use star instead of question mark in that path string. So you've got inflammation dash question mark .csv. You either need 2 question marks or a star, or a single star will give you the right result.
Thanks, Toby. That worked. So the
Great.
question mark only specifies one character.
Yeah, that's exactly right.
Okay, so if I needed to
question mark
two,
matches
then I'd have 2.
exactly one character. Star matches any number of characters, including 0. And that's one of the important things to remember with star, is it will also match nothing. So if you've got a file that's called data/inflammation -.csv, then that will still be matched by this pattern. Whereas the question mark needs to be exactly one character, so it wouldn't match in that case.
So is this where I should
Isaac.
be, in the home or in my terminal?
Sorry, could you repeat the question?
Yes, so this is my home from the web browser. So is it this file, sorry, this place you want me to have a look at? The untitled.
So is that, you found this file called untitled, have you?
Yes.
Okay, great. We'll talk in a moment about how to rename these. I think we didn't talk about that yet, but it's an important thing, because you can end up with like 100 of these notebooks on your system that are all called untitled, which gets really confusing. We'll talk about it later. So for now, if you found where that untitled file is, what I recommend that you do is move all of those inflammation CSV data files to that same location where that untitled.ipynb file is currently, because then they'll be much more easily accessible to you in your current Python session.
Okay, so just help me. How do I find where it's located? Because I see it's
Are you able to share your screen with us, Isaac, if I stop sharing mine?
Yes, I've shared my screen actually.
Oh, sorry, I didn't. Sorry, because I was sharing mine, I couldn't see yours. Right, there we go.
Okay.
Great.
Yeah. It's here.
Okay, yeah. So it does look like it's in your home folder. So then,
Mm.
do you remember where you downloaded and saved the data files to? They're on
Yes,
your
on
desktop,
the
are they?
desktop. Yes, they're on
Okay.
my desktop.
So then, using the File Explorer program in Windows,
Yes.
if you move to your desktop and
Yes.
then grab that go into that SWC, then that
Yes.
data folder, right?
Yeah, this one.
Yeah.
I put it
can-
inside the. Do I put it inside the .ipynb or I should?
No. So I think it's going to be the easiest way to. So the easiest way to do this is definitely going to be to take all of the files that are inside that data folder or the data folder itself and drag it and drop it in your home directory where the untitled.ipynb file is. Probably the better thing to do is to move the notebook file into this folder, because that's where you've got all of the rest of the materials for the workshop. But
Okay.
the downside to doing that is that it's almost certainly going to break it won't break the notebook exactly, but it's going to stop you being able to work with the notebook until you close it and reopen it, because I think it'll really confuse the Jupyter program when the file moves.
Okay.
So can you click the little box next to untitled.ipynb? Great, thanks.
Yes.
And then if you scroll up, then you can click shut down, that orange shut down button. Okay, and we'll have to restart the kernel soon, but then go back to your File Explorer.
Okay.
Yeah, and then go find that that untitled.ipynb file in your home directory.
If you say home directory.
Yeah, so I think is it in the C drive, I think, probably.
Yes.
It'd probably be under users in that previous level. Whichever one you are, okay, yes, this looks good. So scroll down until you find the untitled.ipynb file. It'll be in there somewhere. There it is.
Yes.
And then if you drag that and drop it into the SWC Python folder that you had before, so it'll be under desktop and stuff. It might be easier to open two windows, right? And then you can drag between them.
Okay. So I should come and put it in this one.
Yeah, exactly. Yeah, where you've got the first one that you created on Tuesday, I suppose.
Yes.
Yeah, great. Okay. And then we'll rename it in a moment. So if we go back to the Jupyter interface now, you'll see it's gone. Right. And so click Don't Restart. Can you go left one tab back to that Home tab in your web browser? Yeah. And so now click on Desktop and SWC Python, and click on untitled.ipynb, and that will relaunch it.
Okay.
Takes a moment because it's restarting the kernel. And then can you click where it says Untitled next to Jupyter near the top left?
Okay.
Cool. And give it a more descriptive name.
Okay.
This is not advice only for you. I have probably 25 Jupyter notebooks saved in various locations on my system that are all called untitled, or perhaps they're called like untitled 12 or something. But one of the good practices to try to remember to get into if you're working with Jupyter notebooks often is to immediately rename the notebook when you first create it, because they're always created called untitled. And so give it some like descriptive name that will help you easily identify it if you want to return to it sometime in the future.
Okay, so I just say day 4 lessons.
Yep, cool. Click the rename button. And now if you try running this glob data that I had, so yeah, try running that cell and see what happens. See if you get anything at all. You need to run the cell before first to import glob, because since you shut down this notebook and then restarted it again, all of the history of what's been run on this notebook has been forgotten. So you need to just to rerun some of the cells. That's all. Yep, so glob parentheses and then in quotes data. Let's see what happens.
It's still not lighting up green. I think it should have light. Oh, okay.
There
it's
we go.
Fine now. Yeah.
And so now if you, I'll reshare my screen, if that's all right, and I'll talk you through what comes next.
Thanks a lot.
Yeah, no problem.
Sorry everyone for.
I'm sure you're not alone, Isaac, don't worry. And this is also very helpful because we're recording this and a bunch of people are going to watch it afterwards. I'm sure there'll be people who are watching the recording who run into these problems as well. So watching us talk through how to fix them will be helpful for them as well. So now, because that means that you've got a data folder, you want to run this one. So data/information -star.csv inside the quotes. And you might notice here that I'm using double quotes for my string instead of single quotes. In Python, they're interchangeable. There's no difference in the meaning of double quotes and single quotes. The important thing is to always be consistent about which ones you're using, I suppose, just to make your programs a bit more readable. All right, Isaac, maybe you can give me a thumbs up or something when you're seeing the same output that I've got here.
Okay.
So that I know I can keep moving.
Yes, I'm seeing the same thing now.
Excellent to hear. All right, let's keep going. So
thanks a lot.
Yeah, no problem. My pleasure. So we've got this function call providing us with this. It will provide us with this list of the file names, which we can then use to loop through. So let's store that list as a new variable. We're going to call that file names. And so file names equals glob. Feel free to copy and paste what you've already written if you want, but I'm going to type it out from scratch. So glob data/inflammation -star.csv. Close quotes, close parentheses. Remember, if you don't have a data folder, if you're already in the same location as all of these inflammation files, then you shouldn't include this data/ at the beginning. And when I run this, we don't see any output this time, but instead that output that we were seeing before gets stored as the value of this file names variable. And we can check to see that it is a list by running the type built-in function that you learned about earlier in the workshop. Type file names tells us that this is a list. And because it's a list, we know that that means we can loop through it. We can add things to it, take things away from it. We can sort it if we want to, all of that kind of thing. So let's now go on to actually plot out the same kinds of line plots that we were doing for the first data file for all of the others as well. And this is going to be quite a lot of typing. So I'm going to type it all out because I want to explain what's happening at each step. But if you want to instead watch what I'm typing and listen to it while I'm typing and then copy and paste it in yourself, or copy and paste it in and then follow line by line as I go through it, then that's totally fine. You will find the block of code on the web page that I've just provided the link to in the chat. So let's do this. So we've imported glob. We also need to import numpy, and we need to import matplotlib.pyplot. You hopefully remember both of those from earlier in the Python sessions. NumPy provides all of this like specialized functionality for working with numeric data in Python, and matplotlib.pyplot provides us with all of these tools that we need for creating data visualizations in Python. All right, and we've got our file names already, but what we want is to sort those. So we're going to use another built-in function in Python called sorted. And what sorted does is it sorts whatever you provide it in the parentheses and returns a sorted version of that thing that you've provided to it. So here we're going to overwrite the current value of file names with a sorted version instead. And then we can run our for loop. So for file name in file names. And we're going to do, that means that now the next things that I write are going to be done for all of the files inside that file names list. The first thing we want to do is print the file name so that we know which data we're looking at. And then we want to load it in like we did before with NumPy. So we do, I'll tell you what, I'm going to add a comment here. Load in the data from the current file. Data equals numpy.loadtxt. Fname, that's the parameter for loadtxt that you provide the file name as. So here we want to have fname equals file name. Delimiter equals comma in quotes. So this delimiter equals comma, hopefully you remember, is telling NumPy that it should interpret commas in that file as being the separations between columns in a row of data. And then the next thing we need to do is initialize a matplotlib figure to store the data visualizations. I don't know if you remember, hopefully you still do from earlier in the workshop. We were creating like 3 line plots for the data in the file, and we're going to create those same 3 line plots for all of the data in all of the files. So first, then we initialize a figure that contains all 3 of those subplots in a row. So figure equals matplotlib.pyplot and pyplot contains this figure function, and that figure function creates a figure, what's referred to, I think, often as a canvas for a new figure. And in there, we're going to define the size of that figure. And I suppose because Matplotlib was designed by Americans, the default for the numbers that you provide to fig size is the number of inches for the size of that figure. Anyway, the bigger the number, the bigger the first number, the wider the figure, the bigger the second number, the taller it is. That's the main thing to remember. All right, and then we need to initialize it's a hard word to spell, initialize 3 subplots to appear in the figure. And I don't know if you remember this, but we do that by providing axis 1 equals fig dot add subplot. And then we provide the position information for that subplot. So I should scroll down, huh? So axis 1 equals fig dot add subplot. So this add subplot is a method on the figure object that we created on the previous line. And then the arguments that we provide to that method call are 3 numbers which define the position of this subplot. So the first number is the number of rows of subplots that are going to be contained in the figure. The second number is the number of columns for each of those rows within the figure. And then the third one is the position of this particular subplot. So we're saying we want this figure to have 1 row of subplots, 3 subplots in that row, and this will be the first of those 3. So that's the leftmost of the 3 subplots. And then we can copy and paste this line 2 more times, adjust the name of the variable. So it's axis 2 here and axis 3 here. So we've got axis 1, axis 2, and axis 3. This part's all the same. And then we only need to change 1, 2, and 3 here as well for the position of these subplots that we're creating in our figure. All right, let's keep going. So then we need to perform the same operations for, oh, excuse me a moment. All right, sorry about that. So then we need to perform the same set of operations for each of these 3 subplots that we're creating with our figure. The first thing we want to do with each of them is provide a label for the y-axis to describe the kind of statistic, I suppose, that we're going to be plotting out in this particular subplot. And then the second operation we want to perform is actually telling Matplotlib what data to plot into that particular subplot. So the first part then is to set y label. This is the method on a set of axes to define what the label should be on the y-axis. And this first one is average. I think it's the mean, more technically. And then axes 1 dot plot. This plot method tells Matplotlib what data to actually plot onto those axes. So in this case, we're going to be plotting the mean that's calculated by numpy.mean of data, the data that we're loading in from this particular file. And we have to say axis equals 0 to tell Matplotlib, to tell NumPy whether to calculate this mean column-wise or row-wise within the data, and we want to be calculating it. Column-wise, I think, is what axis 0 means within the data. Okay, let's copy these 2 lines, paste them in twice more. We'll adjust the indentation. So we'll change this to be axis 2, this to be axis 3. And then the 2 things that we need to change now are the label again and the kind of mathematical like statistic that we're calculating on the data for each time. So subplot 2 is the maximum values from this data, and plot 3 will be the minimum values. And the functions from NumPy that we use to calculate these are called amax and amin. And so amax, the reason you have the A at the beginning of amax and amin, I think maybe Kautar already mentioned this, but the reason for this is because it's a maximum and minimum function that you apply to an array. And so the A stands for, is short for array in this case. All right, we're nearly there. The next thing that we want to do is run fig.typed_layout. Talk about why we do that in a moment. And then we run matplotlib.pyplot.show. And this last one, what this does is it actually displays the figure. You finished telling matplotlib how to draw the figure, what to draw into the figure, and so now you tell it to actually display the figure. All right, and like I said, as I promised, I suppose this is going to be a lot of lines of code. So I'm just going to put some more labels in quickly. So define what will be displayed on each subplot. And then what this one does is make the layout of the figure a bit neater and display the figure on the screen. Okay, let's run this. So it's thinking. It's got to load in the libraries to start with, so it takes a bit of time, and then it runs through this loop for all of the file names. So that's going to take a little bit of time as well. But now we've got the number 15 has appeared here. And if I scroll down, you see data/information01.csv with these figures, with these subplots in the figure. Sorry. If I scroll down, we've got the same subplots for information 2, for information 3. This one's funny, huh? Information 4, 5, 6, and so on. We'll scroll right. We'll get to 12. So a few things worth pointing out here, I think. One is that, as you'll see, I hope, we started at 1 and we ended at 12. The file names were sorted. You'll remember that we did that up here. So sort the file names. Sort the file names. And then the next thing to point out, I guess, is that we're getting the same set of figures for each of those data files, one by one. I know it was a lot. That's many more lines of code in a single cell than we've written and run before. As I said, if you don't want to try to type all of that out yourself, you can head to the web page of the URL that I provided in the chat to copy and paste it instead, because you might find that easier to do in this case. But I promised I would show you what the type layout function was doing in this case. So I'm going to comment this line out and then rerun the code. We'll take a look at what things look like without it there. Can you see? This is a nice example here. There's a really tiny amount of space between the right-hand line of these, of this axis box, and the beginning of the label on the y-axis for the next one, max here. And you probably see the same thing for all of them. And there's indeed even overlap here, where you've got like negative numbers on the y-axis for this right-hand plot. Those are even overlapping with the plotting area of the middle plot, and the min label, which actually applies to this axis here, is also overlapping. There are ways that Matplotlib provides for you to manually adjust that kind of spacing. You can have total control over exactly the layout that you've got of these functions if you want them, but this type layout function that's provided, method that's provided with a bigger object in Matplotlib can usually do most of that work for you, just kind of automatically adjusting spacing and sizing and things like that, so that stuff's nicely located next to each other, but still spaced apart from each other. So let me show you what I mean. I'll uncomment this line and then run it again, and now you see there's much more space between these labels and the axis box of the previous one. So here there's no overlap anymore. So that's what that's doing. All right, a lot of information there, I suppose, but also kind of a nice result, because I think this is, I hope you'll be able to understand that this is kind of what we've been building up to as a nice example of how you can use some Python code to automate this process of like plotting the same things out for a large number of data files. This operation could be performed for, here we've done it with 12 data files, but you could do it with 120 or 12,000 files, and it would be the same thing. It would take slightly longer to run, but what it definitely would take is much less time than if you were to try to repeat this same operation manually using like Excel or something to plot out the same set of plots over and over again. If you're working with a really large volume of data files that all share the same format, the same structure, the same number of columns, and the type of data that's in there and stuff like that, then you can write a few lines of Python code to generate thousands potentially of plots to summarize that data, which can be a huge time saver, I suppose. And it's also, you can be guaranteed that the same set of operations has been performed each time. So it's much more kind of reproducible and robust, I suppose, much less error prone than trying to repeat those same operations manually as well. What questions do you have about this code and what it's doing, or about how you might apply this in other circumstances and so on?
Toby, I've got a question on the, I think it's line where you say fig equal to matplotlib.pyplot. Yeah, where you're specifying the figure size. You mentioned 10 is in inches and it's the width of the thing. I find it a bit confusing because in most instances when you talk about matrices and stuff, you tend to start with is it the rows and not the columns. So here we seem to have reversed that. We're talking about, I suppose one could interpret it as the width of the row, which is the width of the figure itself. And then the 3 there. Yeah. So I guess if you interpret it that way, then it becomes, I think it follows the convention of rows and columns. Yeah, I
suppose. I mean, I also think it's confusing, and usually I have to check to remind myself which way round these things are. This time it was easy for me to remember because I know there's going to be 3 and they're going to be in a row because I've seen the I've seen the pictures in the lesson. I know what it's going to look like, so it's easy for me to remember that it's going to be wider than it is tall. But yeah, it just is confusing. And indeed, one of the other lessons that I work on is a data carpentry lesson about image processing in Python, which is actually kind of a good lesson for some of you to follow up with after this one, I hope, if you're interested in doing like image processing with Python. And there, like, the coordinates for a location within an image are it's really confusing whether the first coordinate is like the x-axis, so to speak, or the y-axis in the image. And indeed, if you switch from one environment to another to work with the same image data, sometimes that coordinate system gets flipped around, and it just is really confusing. I'm afraid I don't have the best advice I can give you is to always make sure that you know which one it is. Like, read the documentation, or just try it and see what it ends up looking like. I'll tell you what, should we, just for the fun of it, should we switch these around? So we got 3 and 10, and then rerun the code and see what it looks like. Yeah, so okay, yeah. So it looks like this, because he's trying to squeeze 3 into a row in that same width, and it fills automatically all of the height that you provided. But of course, what we could do is, now that we've flipped the height and the width like that, we could also flip the number of rows and the number of columns like this.
And then you're making it long. And
create vertical sets instead of horizontal sets of plots, like so. But yeah, it is confusing. The only advice I can give you is make sure that you double check so that you're sure that you know which way round you're doing things. Yeah.
Sure, thanks.
All right, cool. Isaac, you got an empty cell when you ran. Did you get some output after a bit of time? Like, did it just take a while for everything to run, or have you still got no output at all? All right, I'm sorry to hear that. I'm going to ask you to share your screen. So for the other folks that are on the call, if you want to stick around and watch while we debug Isaac's problem, then you're very welcome to do so. But once we're done there, we're going to take a break for a little while anyway. So if you've got things working and you want to get up and stretch your legs and go get something to drink or to eat or whatever now, then go ahead, and we'll come back from the break at 10:45 South African time. So in 15 minutes. Okay, I'll stop sharing my screen, Isaac, and you can share yours. Right, Isaac, you're muted on Zoom at the moment, so I can't hear you if you're trying to talk to me.
No, I'm not talking. I'm just showing you my screen.
Okay, cool. No problem. All right, so can you scroll up, please? All right, and what's in your file names list? No, file names is empty. Okay, you need to add the asterisk into the data information minus. So it should be data/information minus star.csv. You don't need to have the dot, but you do need to have the asterisk in there. Yeah. So try running that cell again. You got to run, yeah, you got to run that one first, and then you can run the big one after that. So that recreates this file names variable. So try running this one now. Oh, okay. Figure object has no attribute add subplot. So you're missing the P from add subplot on that line. So this is line, yeah, very good. So those three lines need to have P in add subplot. Cool. Try running it again. There you go. Looks good.
Okay, so this thing, one needs to be very careful with typing and everything.
Yeah, that's one of the real like key takeaways from any introduction to programming is that unfortunately you're going to need to be a lot more careful with typing than we can usually get away with the rest of the time. But yeah, looks good.
Thanks so
and
much.
I promise that with a bit of practice you'll get very used to encountering these kinds of like typo errors and noticing them very quickly. That's certainly one of the things that's happened to me as I've done more programming, is I found it much easier to spot those mistakes than I used to when I first started out.
Yeah, thanks a lot.
All right, enjoy the break. I'll see you in 11 minutes. Okay, can you hear me, everybody? I think so. Okay, first of all, Isaac, can you stop sharing your screen, please, and start sharing mine again? I'm going to do it for you. Let me. Okay, so I hope you enjoyed the break. Before we move on, I would like you to have a go at a couple more exercises. The first one doesn't involve any for looping, but it's good practice with NumPy and with plotting with Matplotlib. So that's this plotting differences. What I'd like you to do is to try plotting the difference between the average inflammation reported in the first and second data set. So that's in inflammation 0.1 and inflammation 0.2. And then the second exercise I'd like you to have a go at is use all of the files, all of the inflammation data files to generate a data set that's the average of all of the values across all of the patients for each of the days in the trial. So to do that, you're going to need to start with this code, although please remember that if you're working with inflammation files that are stored inside a data folder, then you'll need to put data / at the beginning of this path here. Then use this line to create an empty array of all of the an empty array that you're going to store this kind of data as you're adding it all in. Then you will loop through the file names and populate that composite data structure from the files as you're reading them in. Once you finish looping through all of them, you want to average that out. So divide the values that are in that composite data by the total number of files, which you can get by running len on the file names. And then plot out like you were doing before, but instead of having 12 sets of plots, you'll now have a single set of plots that shows the same statistics for that composite data that you've produced from the individual plots. So I'm going to just add a note in here. Remember to add data / oops, sorry. Okay. To this path if needed. Okay. While you start working on the first exercise, I'm going to generate the plots for the second one so that you know what you are hoping to see when you've succeeded in running this, in writing the code for this exercise. And I'll give you until 5 past the hour to do these before we go through the solutions. All right, I've added the plots that you can expect to see if you successfully run the write and run the code for the second exercise. I've added those into the notebook now. All right, folks. Hope that's giving you enough time to have a good go at these exercises. I'm going to talk through the solutions now before we move on to talk a bit about conditional statements in Python. So first of all, we had this exercise asking us to plot the difference between the average inflammations reported in the first and second data sets. In other words, the difference between the leftmost plots of the first two figures. So between this one and this one. All right, so let's have a go at that. The first thing that we need to do is get our data for our first patient. So we'll start a variable called data 0. And we want to load the txt file with NumPy, as we've been doing before. So fname equals, in my case, it's data/inflammation-01.csv, and delimiter equals comma. And then I can copy that, paste it in again underneath, and this time I'll have data1 equals, and then we change the file name to be 02, and everything else stays the same. We could also do this. Another option is to make data 0 be the first entry in the sorted version of our file names. I think the file names are already sorted, so we could do file name 0 and data 1 equals file names 1. That would be another way of achieving the same thing. Comment that out for now, but let's run that. So we've got our data 0 object and our data 1 object. Great. So then the next thing that we want to do is plot. Well, we want to calculate the difference between those, and we want to the difference between the means, sorry, for those, and then we want to plot out that difference as well. So we can do this in two ways. We can initialize the figure, and then we can generate that difference on the fly if we want to, or we can calculate the difference now and then generate the figure to plot it out. And I think I'm going to take the second approach because we want to make sure that the difference is being calculated correctly. So we know we want the average, the mean values of these two data sets to begin with, and then we want to calculate the difference between them. So we can get our mean 0 equals data 0, equals numpy dot mean data 0 and axis equals 0, like we've been doing before, to control in which direction we're calculating these mean values. Mean 1 equals numpy dot mean data 1 axis equals 0. Let's have a look at mean 0. Cool, looks good. And oh, sorry, I pressed the wrong button. Go. Let's have a look at mean 1. Okay, so we've got two arrays here, and so then to calculate the difference, we would say difference equals mean 0 minus mean 1. But you could do it the other way around if you like. It's not going to make much difference. So we've got our difference values now. Okay, great. And so now what we want to do is plot those out. And so we'll do the same things that we did before. So fig equals matplotlib.pyplot.figure. And then we define the size for the figure. We're using 10 and 3 before, but in this case, we're only plotting a single thing. So we probably don't want such a wide and short canvas. So let's say, I don't know, we'll say 8.0 and 6.0, but I'm just picking numbers out of thin air, really. Then we can say, if we only want a single plot on this figure, then we don't need to create a subplot for it. We can plot directly by saying matplotlib dot pyplot dot ylabel difference between means as the label on that y-axis, and then matplotlib dot pyplot dot plot difference. And then let's apply that typed layout method like we did before on the figure object, and then matplotlib.pyplot.show to display the result. I have a error. Value after star must be an iterable, not float. So the problem that I have here is that I didn't tell it what these numbers were that I was providing. So I should have said big size equals, and then these two numbers in parentheses like this. By running that again. Okay, there we go. And so here we've got our label then on the y-axis that says difference between means, and these are the different values between those two files, between the means, sorry, in those two files. All right, so that's the first exercise done. And so now let's move on to the second one to generate the composite statistics. So I gave you some example code to start off with. So let's copy what I gave you here, paste it to our cell down here. First thing I need to do is add data slash here, because I need that in my path, because information files are contained within a data folder. And we've created this this array full of zeros with the dimensions, the size 6040. And so now what we want to do is for each of the files in the file names list, we're going to sum each new file's data into composite data as it's read. And if you remember from the exercises and things that we did in the previous session on for loops, we can do this because we've initialized this empty data frame, or this empty array, or this array full of zeros initially. What we can do now is start adding in one by one the data from each file to sum all of these together. So we've got for file name and file names, we need to load the data in. So we do that with data equals numpy.loadtxt. Same as before, fname equals file name, and delimiter equals comma. And then composite data plus equals, if you remember what that plus equals means, is it's addition and assignment together. So what this is going to do is going to add this data to whatever's in composite data currently and assign the result to this composite data variable. All right, and so that's going to add all of it together, and then as it says here, and then divide the composite data by the number of samples. So we kind of average it back out again. We get the mean of these values summed together. And then we can do the same as we did before to create our figure. So fig equals matplotlib.pyplot dot figure fig size equals 10.3. So because we're going to, as I've shown you here, have these three plots again like we did before. So we want it to be wide, but not particularly tall. So 10 width, 3 height. Axis 1 equals fig dot add underscore subplot, and then position information. So 1 row, 3 columns, position 1. We'll do this 3 times like we did before. So axes 1, axes 2, axes 3, and positions 1, position 2, position 3. Then our first axis should have the y-axis label that it did before. So mean, and we want to plot onto that this sorry, the numpy.mean of the composite data. Axis equals 0. Let's copy these 2 lines and paste in, scroll up a little way. So then we'll do for axis 2 as well. So in this case, it's the max. And instead of mean, we want to do a max. And here it's the min. Do a min. Oh, and I need to change the number here. So it's axis 3 in this case as well. And then if we finish this off with the same combination that we've been using up until now, which is fig.tight layout to make the layout of the figure a little bit neater, and matplotlib.pyplot.show to show the final result. Let's run this and see how it looks. All right, does it look the same as the picture I put in above? It does. So this is combined all of these things together. Let me show you what's happening, I guess, on each step of the way. So we can print composite data here. And then we can print composite data here as well. So copy that line, paste it in down here. And then we can print it here too, before we then do all the plotting. So to begin with, the composite data array is just a bunch of zeros. That's what the numpy.zeros function is doing. It's creating an array in the dimension 6040 filled with zeros. And then after this for loop, this line shows us this output here, and that's showing us the numbers from all of the files, like the total in each position from all of the files combined together. And then finally, when we print it out after dividing by the number of file names, then we get this one here, and it's these values that then actually get plotted out. All right. What questions do you have about any of that before I move on to the next section? Okay. Oh, I see a question in the Q&A section now. Please explain again what the code is performing. The composite data plus equals data. Yeah, sure. Happy to. So what is where am I? Sorry, I've got too many windows open, slightly confused. Here we go. So yeah, this line here is equivalent to composite data equals composite data plus data. So what this plus equals is doing is equivalent to this operation. So it's adding this to this and then assigning the result to this. And so because this part and this part are the same, we can actually use this plus equals operator to say, add the thing on the right-hand side of it to the thing on the left-hand side and assign the result to the thing on the left-hand side. And so in fact, down here where we've got composite data equals composite data slash, so divided by the length of the file names, this could be rewritten as slash equals instead, and it would be the same. It would achieve the same result. I hope that answers your question, Olashula.
Yeah, thank you.
All right. So now we're going to move on to talk about, I think, the last really important kind of like programming concept, I guess, the kind of really important building block in terms of syntax and how to think about your programs as you're writing them. And with whatever time we've got left at the end of the session, I'll give you a few more pieces of advice, I suppose, about how to work with Python and how to find things out and so on. And then right at the end of this session, right at the end of the session today, we'll do a little bit of preparation for the Git and version control lesson that I'll be running through tomorrow. So in this section, we're going to talk about how you can tell your code to do, you can tell your program to do different things depending on the data that it receives. And so by the end, you're going to be able to write your own if statements and else statements and so on. And you'll also be able to interpret what result you're likely to see from combinations of conditionals, including and or. All right. So the most important thing for you to learn about right at the beginning of this is these statements that you can write in Python that start if or else or in between them. There's also elif, and we're going to take a look at those in a moment. So we combine these together to build up multiple blocks of code where the different blocks will be run depending on the circumstances. So usually depending on the data that's being read into the program and what the values are of that data. So to give you a relatively simple example, let's take a number and we'll say 37 for the number, and then we can say if number greater than 100, and a colon like we had with the for loop. And then when we press enter, our cursor jumps to the right. We get this indentation, and just like with the for loop, what we're defining with this indentation is the code that will be run under this condition. So we'd say print larger than 100. And then we can write else. That's without the indentation now, and a colon again. When we press enter, the cursor's indented again, and in this case we write not larger than 100. Let's run this. Our number is 37, so it's not greater than 100. So let's see what we get. So we get not larger than 100. And the way that this program is interpreted by Python is first we create this variable called number, and then this if number greater than 100, that gets read, and Python tests whether the number that it's been given, whether the value of this variable called number, whether that's larger than 100. If it is larger than 100, then this line of code gets run. Otherwise, this line of code gets run. And so what happens if it's larger than 100 is we get this printed out, and then we skip past the else and what happens with the else. So if I change the number to be 137 and rerun it, instead of editing it and rerunning it, I'll paste it into the cell below, and I'll edit it there and run it here. We see we get larger than 100. And so with this kind of pattern, I guess, in our code, we can define chunks of program that will only be run under certain conditions. And if we want to have more options, I suppose, than only these two options of if or else, then we can put elif statements in between. So let's show you what I mean there. So we'd say number equals 37 again, and we can say if number greater than 100. I'll tell you what, I'm going to paste in what we had before to save me typing all of this again, but number equals 37. If number greater than 100, print larger than 100. And we can put elif here between the if and the else. And then after elif, we need to provide another condition that we're going to be testing here. So we could say if number is exactly 37, and we define is exactly with this double equals. So we have to use two equals signs together as a test of equality between two values. The reason that we have to put two equal signs here is that if we include only a single equals, well, in Python, a single equal sign is used as a assignment operation. So assigning the value on the right of the equal sign to the thing on the left of the equal sign. And so if we instead want to refer to two numbers, in this case being equal to each other, then we need to use double equals as that to signify that test of equality. Then we would print exactly 37 and an exclamation mark afterwards, and then close the parentheses, else not larger than 100 and also not 37. And so when we run this, the code block after the if statement doesn't get run because our number's not larger than 100. And our code block under the elif statement does get run because our number is exactly 37. And then the code block under else also doesn't get run because that's the what you define after else is the kind of catch-all. What do you do if none of the conditions have been met, but one of the conditions has been met, so the else doesn't get run. I suppose before I move on to start looking at some of our data, what questions do you have about this kind of structure of if and elif and else?
I've got a question on, let's say you've got a condition, like you have the first if number is greater than 100, right? Let's say I have three intervals that I want to check. Let's say 0 to 30, and then between 30 and say 60, and then above 60. And I want to say this belongs to this category and stuff. How do I specify that?
So that would be defined largely by the order in which you provide these. So you can think about how, like, if the number isn't less than 30, then you can have the next test to be, well, is it less than 60? Because if it is, then you know then that it must be between 31 or between 30 and 60 in that case.
Mhm.
And then the last one would test whether it's above 60. So let me show you what I mean. So you could say if number less than 30, print less than 30, elif number less than 60, print between 30 and 59. I guess, 59.9999999. Else print 60 or more. And that would be your tests, because they're run one after the other. So you know if you get to this test, I forgot my colon there. You know if you get to this test that this test hasn't succeeded. And you know if you get down to the else that neither of the two above have succeeded. However, if you want to test whether it's between 0 and 30, then you need to start combining these conditions together. And I'm going to talk in a moment about how you do that. Okay, so let's talk a little bit about some other comparisons that you can have in Python. I'm going to put this in Markdown. So for comparison operators in Python. So we can have greater than, we can have less than, we can also have greater than or equal to, less than or equal to. And then, as I've shown you, we've got equal to, and the opposite of that is exclamation mark equal sign, which means not equal to. There's more than that. You can do like binary operations and things like that as well, binary comparisons. But for now, I think in most cases, if you're doing like numerical analyses and things, these are the main ones that you want to know about. Okay, good. So then combining them together, let's say that you want to do the same as we were providing before, but instead of having only if it's less than 30, you want to rule out that it might be negative, then you would say if number less than 30 space and number greater than or equal to 0. And so that would define that it needs to be in the range of between 0 and 30. Let's change our number here to prove that it works. So number equals 29. It's less than 30. What if we change it to minus 29, negative 29? Well, then we get elif number less than 60 works, right? Because minus 29 is less than 60. So you either need to add this and number greater than or equal to 0 to all the conditions to get past this, but then you also need to adjust what output you get from the else, right? Because the else is going to run if none of the previous conditions get matched. But now that doesn't mean that else is telling you that the number is definitely greater than 60. And this is one of the things that is really important to keep in mind, is exactly what you're saying with your conditions. Or a negative number is actually what this is telling us now. And if instead we want to, first of all, make sure that it's not a negative number, then instead we would need to adjust all of these conditions to be like, so that the first one is if number less than 0, print stop. This is a negative number, or you can then define some behavior that your program should have when it encounters a negative number that it's not expecting. And this comes into some of the stuff that we should talk about later in the lesson, that's often referred to as defensive programming. So writing your program to notice problems with the input data as early as possible, so that you don't wait for 10 minutes for your program to run only to then find out that there was something wrong with the input in the first place and you wasted that time. So you would put if number less than 0 first, and then after that you would check if the number is less than 30, because then you know that it must be between 0 and 30. Print between 0 and 30, etc., etc. Else print greater than 29. Okay, but yeah, so you can have and operations like this that will test 2 conditions. You can test more than 2. If you wanted to test a third one, you could say and number not equal to 17, for example. And you can combine as many conditions together as you like with these AND operations, and whatever block you provide underneath that will only be run if all of the conditions evaluate true. If you want something to happen under 2 different conditions, so we can say, for example, if number greater than 0 or number less than 0, print number is not 0. Else print number must be 0. So, right, the only circumstances under which we would get to the else is if our number was neither greater than or less than 0, and so that means that the number must be 0. And so OR conditions, like if you're providing OR to combine conditions like this, then your block underneath that statement will run when either one of those conditions evaluates to true. And both can evaluate to true as well, that's fine. But as long as at least one of them evaluates to true, then you'll see the output. And when I say evaluates to true, I think it's a good idea for us to show what that means. So if you print this condition that we're using in the if statement, the result of that is true, because our number, let's print the number to remind you what it is. Oops, print number and then print the condition. So our number is currently -29. But if we change here the number to be 0, and then print out a number 0, and now the result of this when we're printing out shows false. And so that's what Python's actually doing. It kind of runs these conditions internally, and it returns these special values that are either true or false. They're referred to as Boolean variables, true or false. And then if it returns true, then the block under that if statement or elif statement or else, no, I suppose elif or if, that gets run. If it returns false, then it doesn't get run. What questions do you have about combining these conditions together, or about the existence of these true and false values? All right, so I need to remind you of something from earlier in the lesson. So just quickly share another tab. So hopefully you remember when you first started plotting out this data, we were working only with the first data file, so inflammation01.csv. And we plotted out the mean of the inflammation values there, and it looked like this. So raising fairly steadily, and then peaking at day 20, and then dropping at about the same rate. We showed the maximum values then, and this looked really suspicious because it's a perfectly like straight increase of 1 per day right up until day 20, when the maximum reaches 20, and then it drops back down again to be 0 by day 40, exactly 1 unit per day, which looks suspiciously clean, I guess, for what's supposed to be biological or like biology related data, biomedical data. Is very unusual for a biological system like inflammation or whatever else to exhibit this kind of perfect uniform pattern. So there's probably something a bit weird going on with this data. Let's use our newfound ability to write if and else statements in Python to do a bit more testing of this kind of thing across all of our data files. All right, so the first thing that we want to do is import NumPy like we were doing before. And let's import matplotlib.pyplot as well, just in case we need it later. I'm running that. If you haven't started a new notebook and you're still working with the old one, you probably didn't need to do that. And so what we're going to do, instead of looking at all of the data, what we'll do is we'll check the value, the maximum value on the first day, so day 0, and the maximum value on the middle day, day 20, and check whether those equal 0 and 20, so that we've got an idea of whether there's that same kind of suspicious pattern in the data showing up. So we'll say, we got to import our data first. So data equals numpy.load.txt. In my case, I've got this data folder, so data/inflammation 01.csv, and delimiter equals comma. And then we're going to say max inflammation day 0 equals numpy.amax, so getting the maximum from an array, it's data array, axis equals 0. So this is the same operation we've been doing a bunch of times before when we've been plotting things out. But instead of plotting stuff out, we're going to take the first entry in this, and we're going to repeat this for the 20th day as well. So day 20, we put 20 here. And then we can say if max inflammation day 0 equals, so is equal to 0 and max inflammation day 20 is equal to 20, print this data looks suspicious. On this, and we know that this is the case for the first day, so we knew that this was going to evaluate to true. But we could take this and write a for loop again. So import glob. We need to do that because I've started a new notebook, and then we do file names equals glob. You don't need to do this unless you've created a new notebook like I did, but data / information - start CSV. File names equals sorted file names, and then I'll just put a comment here. You could also run file names dot sort to achieve the same thing. So just so you know, lists also have a sort method that you can run to sort the values in them if you want to instead. Okay, so now I've got our file names. I can run for file name in file names, and then we're going to repeat this entire thing. So our data is loading. Instead of this, we put file name to load the data from that file. We get the 0 and we get the 20, and we run this conditional. And I suppose just before that, we need to put print file name so we know which file it's talking about on this. And so sure enough, for most of our files, 1, 2, 3, 4, 5, 6, 7, 8, 9 of the 12 files, we see this kind of suspicious pattern in the maximum values within the data. And if we wanted this output to be a little bit more easily readable, instead of putting print file name here, I'm going to comment that out. I'm going to say print the data in, and then close the quotes there, put a comma and put file name here and another comma, and then reopen the quotes here. If we run the print statement like that, then we get the file name embedded in the print output. This tells us. Another thing that we could do if we wanted to is use those lists again and the append method that we saw before to say to create a empty list outside of the loop, suspicious file names, suspicious files, let's call it, equals empty list. And then as we go through this, instead of printing out, we can say if these conditions are met, then suspicious files dot append file name. And then after the loop is finished, we can say print list of suspicious files, colon, close quotes, space, and then file names, like this, and get the same kind of thing. But here we would then be capturing those file names in a list, because we might want to then do something else with those specific files that we've identified as suspicious in our program. And so we'd separate those out And what if we wanted to not only build up a list of suspicious files, but also build up a list of files that look okay? So we could say, I don't know, validated or something. Validated files would be the other kind. So we'd create an empty list for that. And then, as well as appending the files where the conditions are met to the suspicious files list, we could say else validated files dot append file name. And then we can say these files look suspicious, and we could say these files look okay. I gave the wrong thing here, sorry. So this should have been suspicious files. And then this one should be validated files. There we go. So we get these files look suspicious, and then this list, and these files look okay, and we get this list. Furthermore, we could say, instead of showing the actual names of files, we could say print len suspicious files. Files look suspicious, and here we can say len validated files. Space here. Files look okay, and if we run this, then we get a count of the number of files that look suspicious and the number of files that look okay. So 9 files look suspicious, 3 files look okay. And we can start to combine all of these things that we've been learning together, the for loops, the lists, the built-in functions like len, print, and so on, as well as the conditionals like if and else, to start to build up these programs that can quickly run through all of this data and summarize for us how things are looking. We can loop through it all and generate these plots. You know, perhaps we only want to plot the data for the files that have been validated, for example. So we could then, after this, we could say for file name in validated files, and then we could paste in the code that we were using before to generate the figure and to plot out each of those subplots only for these 3 files that have been validated. So let's go and get that. So that's here. Or close enough, I can fix the rest. So I'm going to select all of these lines. I'm going to press tab, and that's going to indent all of them all together. If I hold down shift tab, then it unindents them, moves them back to the left. So that's another thing that you can do to save yourself some time. So we're going to do this only for the validated files. We create a figure, we create these axes, we add the plots, but instead of, so we need to as well load the data back in. Grab this line from up here, paste it back in again. So we're loading it from the file again. It's data here. Then we're making our figure. We're adding the subplot axes to the figure. We're plotting out the maximum and the minimum in each case. So put here print displaying plots for validated data only. And we run this whole thing. So it's checking through all of them. This is like this loop's doing that validation. It's giving us a summary of the results of that validation. And then we're only displaying the plots for the 3 files that have passed the validation, which is these 3. All right. Um, so what questions do you have about what I just went through there? Or anything else to do with these conditionals, I suppose, and how to use if and else and so on before I move on to some other good practices. Okay, I don't see any questions coming in or hear any questions coming in. So I'm going to set you another exercise. This is one for you to think about, really. And then we'll take a short break before we come back and finish things off for today. So what this exercise asks you is, it tells you, first of all, that true and false are not the only values in Python that are considered true and false. And in fact, you can use values of variables or whatever values you like in if and elif. And to try to give you an idea of which values will be considered, like under which conditions Python will consider something to be true or to be false, this code block is provided to you. What I'd like you to do is type that out into your system and run it. You can do each one individually if you like. They don't have to all be in a single block. And look at what the result is and think about what the rules seem to be for whether something is considered true or false by Python, depending on whether it's a string or a list or an integer. In this case, this will show you different ways in which Python can behave with different values for those different types of data. So I'm going to give you a few minutes to run through this yourself, and then we'll talk through the results. And then I think we'll take another short break before we move into the last part of today. All right, let's see. Can you hear me? I hope so. Yeah, it looks like you can hear me. Good. Okay, so I've given you a bit of time to look at this exercise, and hopefully you've started to figure out what some of the rules are, I suppose, for how Python thinks about these things. Would anybody like to tell me how Python treats strings, I suppose, in if statements? So what do you need to have as a string for it to be considered true or for it to be considered false?
Anything that's non-empty is considered a string, I would assume. So any character is considered a string.
Yeah, that's right. So as long as the string isn't empty, then it's considered true. And if it is empty, then it's false. And pretty much the same principle applies to lists as well. So if you have a completely empty list like this, so this is how you would write an empty list in Python. That's false. But otherwise, if the list contains even one element or more, then it's true. And with integers, if 0 is equivalent to false and 1 is equivalent to true. So if we actually copy this, paste it in, we'll see in each case that it's the second condition that gets evaluated to true. Yeah, and so that might seem a little abstract, I suppose, or kind of conceptual, but it's important for you to understand, because if you're when you're writing your programs, if you're doing that kind of like data validation, for example, and you want to make sure that the data that you're reading in is kind of not null, I guess. So like you haven't accidentally not got a file name, for example, as some of you might have seen earlier. I can give an example here. So glob.glob, and then some path that doesn't exist. So not here. If I run that, then what I get is an empty list. So there's no error. The glob doesn't tell me, hang on a minute, I think you've done something wrong. And so the program doesn't stop. It would keep running, but you might not want the program to keep running under these circumstances. If there's no files that match the pattern that you're providing to glob in this case, then you might want to stop there and then. And so you can actually write code that says if glob.glob not here, you know, do some cool stuff with the files you found, else print no files by that name here. Oh, I missed out. I have to provide something in this block. So in this case, we could just print it's the parenthesis there, sorry. There we go. And so you can do it directly this way instead of what you'd have to do otherwise. It's like run this and capture it as file names, something. And then you'd have to test whether if then file names greater than 0, right? So this would be the equivalent. You'd read the file names in, and then you test whether the length of that list that was created was greater than 0, and do the same stuff. But you can save yourself some lines of code by actually doing the test directly on the result of the function in this case, if you want to. Okay, let's take a break for 7 minutes. That'll take us to 12:15. And then we'll come back and we'll do the last parts to wrap up today, to finish up Python and lay the groundwork for our version control with Git and GitHub session tomorrow. Thanks for listening. See you soon. So, welcome back. Just turn my video back on. Cool. And then share my screen again. All right. So the first good practice that I want to make sure that I tell you about during this during what remains in this session today is about how to create functions in your programs. So generally speaking, the practice that I want to encourage you to get into is that any time that you find yourself running the same kind of chunk of the collection of commands that you've written, the same chunk of code that you've written repeatedly, it's a good idea to try to encapsulate that in a function, and then you can call that function and that will run that chunk of code that you wrote on demand, I suppose. So I'm going to show you, if that seems a little abstract at the moment, I'm going to show you now how to actually do that. And then I'll talk a little bit more after that about why this is such a good idea to try to capture things as functions like this. The example in the lesson shows how to do a conversion between temperature in Fahrenheit and temperature in Celsius. We'll do it the other way around because we probably, I don't know, I'm used to thinking temperatures in Celsius, and I usually need to do the conversion to Fahrenheit. So let's do it that way around. Okay, so we'd have our Celsius value is, let's say, 36, and then our height Celsius temp and Fahrenheit temp equals trying to figure out how to do it the other way around. Okay, I'll give up. I shouldn't try and work this out on the fly. Let's do it the way that it's written in the lesson. So Fahrenheit temp 99, Celsius temp is equivalent to Fahrenheit temp minus 32 multiplied by 5 divided by 9. Celsius temp. Okay, great. So we've got this, but then we might want to perform this kind of conversion operation a bunch of times and a bunch of different temperatures. And so this is a nice example of something that we could define as a function. And so to define this kind of conversion as a function, we would type def, def, and then a space, and then we give a name to our function. So I'm going to say convert C to F. Sorry, see, I'm getting it the wrong way around again. Convert F to C. And then we tell it what value to expect. So temperature in Fahrenheit is what we're going to call this input variable. And then we put a colon and we press enter. And what we're defining here is a new function that's going to be called convert F to C. And we're telling Python that that function will expect to receive a single piece of information, which is this temperature in Fahrenheit. And so then we would say temperature in Celsius equals, I can take this operation here, copy that, paste it in, adjust this name of this variable to match up to the one that was defined up here. So temperature Fahrenheit here matches up to the name that we've given to the input variable up here for our function. And so what will happen when we run our function is that it will calculate and create this new variable called temperature in Celsius based on the value that's provided as input. And then the last thing that we need to do is tell our function to return that temperature in Celsius variable. And this return statement you'll see here, it's turned green as well, which means it's got a special meaning to Python. What this does is it tells Python what the function should kind of give back to the user when the user calls this function in the future. Let's show you what this means. So we can then create another temperature variable that we're going to call temp equals 75. And then we can run our convert. So I'm going to start typing this, and then to prove that it exists as a function now within our environment, I'm going to press tab and the rest gets filled in. And then I provide temp in the parentheses there. Like that, and we get 23.88888888. Those are the answer. So type, convert F to C, and then put whatever other number in as well that I want, 110, be 43. And hopefully you get the idea. We have defined now this function, and we've said what it should do. And then when we call it, the calculation happens, this number appears. We can capture that number, converted temp equals convert blah, 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 temp. And now we don't get the output, but if we print converted temp, then we see that number that we captured before. Okay, and so let's have a look at that definition one more time. The important elements are you start with def for the function, then a space, and then the name of the function. Then you open some parentheses, and inside those parentheses, you provide the variables that will be the inputs for that function. In this case, we've only got one, but you could have 3 or 7 or whatever. And then you close those parentheses, add a colon symbol. Then you have one or more indented lines, and those just like with the for loop or the if statement, the indentation on those lines tells Python that these lines belong to that function definition. And once you add some more lines that aren't included, that don't include that indentation, then Python will know that those lines aren't part of the function definition and that you've finished defining your and then I suppose the last part that's really important to point to is the return statement, which tells Python what the function should give back to the user when the user calls this function after it's been defined. And so what we can do, with this kind of approach is we can start to package together these particular operations that we tend to want to do on our data into functions that we can then call on demand when we need them, and that saves us a lot of typing because we only need to type this code out one time, capture it in this function definition, and then we can call that function each time instead of having to write all of those lines of code every time. So let's go back to the plotting that we were doing before, for example. We kept seeing this pattern a bunch of times, right? Where we were creating a figure, then we were creating the 3 subplots for that figure, and then we were plotting the same kind of summaries of the data each time. The only thing that was changing each time that we ran through this operation was the data that was being plotted out itself. So like the input data to these NumPy functions to calculate the mean and the max and the min, for example. So we could, if we wanted to, define another function, and we'll call this function plot summary statistics. And what this is going to require is some input data. So input data. And then we can say inside the function, we can have these lines like so. Again, I'm going to select them all, press tab to indent them all together. And we say fig equals matplotlib, blah, blah, blah. We create the subplots the same as we were before. We set the Y label the same as we did before. And we plot out numpy.mean of the same as we did before, except instead of composite data here, we have input data to match up with the name of the input variable that we're defining for this function. We still apply this type layout to neaten up the layout of the subplots in the figure, and we still show the result as well. And in this case, we don't really need to return anything because the function call is going to create the plots and show the plots. And so there's not really a need for a return statement in this case. I've defined this plot. I suppose actually before I do that, because I've started a new notebook, I need to run import numpy and import matplotlib.pyplot. And I suppose I'm about to use glob again to get those file names again. So now I'll run those. I've defined this function. And so now I can get my file names again, same as I was doing before. So file names equals glob.glob, data / implementation -star.csv. And then I can run my for loop like we were doing before. So for file name in file names. But then instead of, okay, so then I still need to load the data in. So I'll say data equals numpy.load txt. File name, delimiter equals comma. By now, hopefully you've got as familiar with these lines of code as I have, because we've been writing them quite a lot. But then instead of writing all of that plotting, all of those plotting lines again, we can say plot summary statistics data. We get the same output that we did before with these plots. But with now only 3 lines of code, 2 lines within the loop, because we've put the rest in up here. And so then hopefully you remember that, as well as kind of plotting them all out like this, we did a bit of like validation, where we wanted to check whether the data in the files looked weird or not. And if it didn't look weird, then we plot them out. So we could repeat that here now and call this function again to plot those summary statistics, instead of having to write it all out and repeat ourselves again in the function. And I guess another part that we could capture, because we've been writing a lot of this as well, is that we could say, we could define another function that's called like def load data arrays, and then we'd have the input variable would be path to files, and in this function we would include the file names equals glob.glob path to files, and then for file name in file names numpy data arrays equals empty list numpy.load. Then we'd say data arrays dot append numpy.load txt file name limiter equals comma again. All right, and so with this function, we could also automate this process of loading in a bunch of files from a particular location, and you get, in the end, all of those arrays stored in a list. One of the downsides to taking this approach is that if you store all of those arrays in a list and you load in like 1,000 of those arrays, that list is going to take up a lot of memory in your system. Whereas the way that we've been doing things up until now, where we've been looping through one file at a time and only ever loading in a data array for that particular file, is the memory requirement for the program is much smaller, because the maximum amount you're storing at any one time is only the data from a single file. Whereas in this case, you'd be loading all of the data from all of the files into memory at once. And that might be something that you need to worry about. But it's another example of a function that you could write to kind of automate a process that we've been running over and over again in our code. All right. The last thing that I want to tell you about function definitions is that you can and you should write documentation for your functions. And so the way that we can do that, we can, of course, make them self-documenting by using a name for the function that's quite descriptive of what it actually does, and using names for the variables that are used within it that are quite descriptive of what they do. But we can do even better than that. If the first line of a function definition is a string like this, just a string not assigned to any variable or anything, but just a string, we can say plot out some summary statistics for an array of data. So we can add a string like that. This is valid Python syntax. We don't get any errors. And then one of the things that's really nice about this is, I can show you here, if I run the help built-in function on this function that we've just defined, then the output of that shows me here This is what's been referred to so far as the signature. So it tells the user how to use this function. And then underneath that is this string that I defined there, which is referred to as a doc string. And in particular, what you'll very commonly find with the way that people write functions, and what I encourage you to do with yours as well, is if you use triple quotes for opening a string, triple single quotes for opening a string like this, you can split that string over multiple lines without breaking the syntax of Python. So we could say plot out some summary statistics for an array of data. But instead of being vague like this, we can say plot out the mean, maximum, and minimum values in an array of data. Put this on another line, in an array of data, column wise, I think is how we were doing it. And we can put some empty lines in if we want to, and we can also say arguments and then provide some information about the arguments that it expects. In this case, it's only one argument, so input data, and we can tell the user a little bit more about what we want that input data to look like. So we could say at a two-dimensional array of numeric values. And then we can say returns. And in this case, we can put that this function does not return anything. Let's rerun this cell with the function definition. We've still got all the function body underneath this, but now we've got this string between triple quote marks. And if we now rerun the inbuilt help function on this, we get that full doc string as output in the help call. And so when you're writing your programs, I recommend that not only do you try to capture things in functions, but you get into this habit of writing these doc strings, as they're called, so documentation strings, at the very beginning of the function definitions. These will be really helpful for anyone else who uses those functions, but they'll also be really helpful for you in another like month's time or whatever, when it's no longer so fresh in your mind what that function was supposed to be doing when you were defining it. If you combine all of these techniques, capturing things in functions, annotating your code with comments, using descriptive function names and variable names and so on, and also adding these doc strings at the beginning of your function definitions, it will make your programs much easier to read and much easier to reuse. And it's going to save you a lot of time and confusion in the long run, because you won't need to spend as long relearning how this program works each time you return to it. Okay. What questions do you have about function definitions and doc strings and all the other things that I was just talking about? Okay, I don't see any questions coming in. We've got about 20 minutes left today. So what I would like to do is return to the Etherpad. So I'm going to take the questions that you all wrote yesterday. I'll share the link again in a moment if you need it again. What questions do you still have about Python? And we answered the one about splitting a sentence up into words yesterday, so I'm going to remove that one. And this is from line 183. So there's the link to the Etherpad, and the list for questions is from line 183. Stop sharing my screen from, well, no, I'll leave the screen sharing on because I'm probably going to need it while I answer questions. But please head over to the Etherpad, find that section where I'm asking you what questions you still have, and have a think and write in the questions that you have, and I'll try to answer as many of them as I can. Right, so we've got a few questions in the pad now. I'll take them from top to bottom, I guess. I think the last two questions are pretty similar, I suppose, in terms of the way that I'm going to try to answer them. So first of all, there's the question, sort of general question about, given that there are such a huge number of different functions and different libraries and modules and things that you can import into your Python programs, and all of those functions and everything have a lot of options and parameters and stuff like that that you can define for them. How do you get to know what to do in different circumstances? And I guess one answer to that question is like, if you register and enroll in some like official longer term Python programming course, then there'll be more opportunity for people who are already experts in this stuff to like tell you and for you to learn that in a structured way. If like me, you're going to leave this workshop and then you're going to be largely figuring this stuff out on your own after that. Well, first of all, I hope that this workshop's prepared you a lot better to be able to do that than if you were just starting out from zero and trying to figure this stuff out on your own. But secondly, it comes from a lot of looking stuff up online, reading the documentation of things and trying to figure out what the best ways to do things. And then every now and again, someone saying to you, oh, you don't need to do it this way. There's this other thing that exists and you can use that, which is usually a magical moment, if a little bit depressing sometimes. In one case, someone showed me how to do something that I just didn't know existed before. And it saved me, it made my program run something like, I think it was like 160 times faster than it had been running before. And I'd been spending so much time sitting and just waiting for this program to run. And then they showed me this one thing that I could do that I just didn't know existed. And suddenly it ran like quick as a flash. And all of that time that I'd already spent sitting around waiting for it to complete, it turned out had been wasted. But anyway, unfortunately, like unless you take like a really structured coursework approach to learning about this thing in depth and then learning about this thing in depth, guided by some expert, you're going to be figuring a lot of this stuff out as you go along. And so the main pieces of advice that I can give you with doing that are don't be afraid to search for answers to questions about how to do things on the internet. So really common. Let's say, for example, we looked at the example towards the end of yesterday of splitting that sentence up into multiple words. And I said already that one of the things you need to watch out for is the special characters that are contained within sentences, because they'll often be like a comma at the end of a word would still be included as part of that word when you do that split operation. So what's the best way to make sure that you don't include any of those characters when you're trying to get the words from a paragraph or from a book's worth of text or something? I don't know the answer to that question. So let's try and find out. I'm going to open a new tab in my web browser and I'm going to search. I use the DuckDuckGo search engine. So we're going to use that here. How to get words without special characters from long string Python. So asking the question, making sure that I include the word Python at the end so that the search engine prioritizes answers that are to do with the Python programming language. And right away, the first answer that I get from my search engine here is a Stack Overflow post. So Stack Overflow is a very popular website where people ask programming related questions. I can click on that and it says, I need to remove all special characters, punctuation and spaces from a string so that I only have letters and numbers. Okay, sounds good. And what Stack Overflow does is it provides you with a list of all of the answers that people out there on the internet have provided to this question. You can see there's 19 of them. And they're sorted by default by the highest score. So Stack Overflow users can rate the helpfulness of answers. And depending on how high rated those answers are, they get bumped further up down the list. And so this one has a score of 539, which is a pretty good score in my experience with Stack Overflow. So probably this is a useful answer. It says this can be done without regex. You don't need to know what regex is for the purposes of this lesson, but it stands for regular expressions, in case you're wondering. And so we've got a string, an example string with some special characters in it. And then what they're doing is joining with an empty string here, E for E in string if E is alnum. So it's this part's crucial. Strings, it turns out, have a is alnum method with them that returns true if it's alphanumeric, so a letter or a number, or false if it's some kind of special character that's neither a letter nor a number. And what they're doing here is calling string.join and running through all of the characters in the string, but only keeping the ones that are alphanumeric. And then the empty string.join glues all of those back together into a single string. So you don't really need to know everything about what's going on in this line. The point is the pattern here. We wrote it into a search engine, we pressed go, we opened Stack Overflow, and we found already a very helpful answer. Then if we wanted to find out more about exactly what's going on here, we could go back to our Python program, and we could type empty string.join with a question mark afterwards. Oh, sorry. Test string equals empty string test string.join. I've forgotten. There we go. And then we can read the documentation for that join method on the string to give us more information about exactly what's going on here. Because very often you open those Stack Overflow pages and the answer that someone's giving involves an element of Python that we haven't ever encountered before. That is alnum method, for example, to test whether a string is alphanumeric, or this .join method. We hadn't encountered that before. So it's usually a good idea under those circumstances to go and read up a little bit more about what those are doing, because who knows, they might, once you've learned that, not only have you learned it anyway, but it might also be immediately useful in another situation that you're handling at the moment in Python. Plus, of course, it's important to stress, it's not necessarily a good idea to just copy and paste code that people have written on the internet and run it on your computer without knowing what that code's going to do, because there's always the chance that it's actually going to really break something on your computer. You can't necessarily trust random people on the internet all the time. Now, Stack Overflow's system of like rating answers and then showing the top rated answers more highly, that's a really helpful way to gain kind of trust, to build trust in the answers that you find there. But if you search and you find Stack Overflow post and you don't see a big score like 500 and something next to that answer, then it's a good idea to make sure that you really do understand what that code that they're providing is going to do before you run it. Just because, you know, if you run it and it breaks everything, then it's broken everything and you're in big trouble. The other thing I want to stress about this is that score there on that Stack Overflow post, like 500 and something, right, for that answer. What that tells you is not only has one person had that question before, the person who wrote the question into Stack Overflow in the first place, but also like at least nearly 600 other people have come to Stack Overflow and looked for the answer to that question and then have rated that answer highly because it's worked for them. And I hope that makes you feel less alone in this process of learning programming and feeling all the time like you don't know how to do stuff and you're constantly having to go and ask the internet in order to keep making progress. You are not alone in this. There's been many people out there, including me, before you, who have also been going through that process and have asked these questions in search engines or on Stack Overflow or whatever. And it is unfortunately just part of the process in terms of learning how to do this stuff. And over time, you'll remember more and more of this as you encounter it, and you'll get better and better at searching for things and knowing what the right words are to use to search for things on the internet as well to get the answers that you need. I see that there's a question that popped up and so if you can access things through the built-in help, like I was just doing here, because they're like NumPy or something, like a special library that you need to install and import to be able to use it, then search the internet for the documentation for that library. Usually these libraries, if they're very popular, they've got really good tutorial resources and documentation that you can read to help you understand what you need to do and how you need to use those programs. There's a question now in the Q&A section. So this says, let's say you have a function that returns 2 or 3 variables, but you're only interested in one of those variables. How can you extract only that one variable? You can't, I suppose. You have to accept that you're going to get all of them, but you can usually like discard the others by just not using them in the rest of your program. I think that Python does have it's like a del statement, I think, to delete a variable. If you're worried about that function returning a bunch of stuff that's going to take up a load of memory in your program, I think that the best thing you can do is explicitly delete those things. I suppose the other thing that you could do, that's def returns 3 things. I'm going to create a function that returns 3 things. I'm putting empty parentheses because it runs without expecting any input at all, and it's going to return 1, 2, and 3 as the values. That's a valid function. Let's run returns 3 things. We get 1, 2, and 3. You can capture this with 1, 2, 3 equals returns 3 things, print 2, just to prove that it's working. Okay. And then if you know for sure that you only want the one thing that it returns, like the first thing that it returns of the 3, then I suppose you could do it like this. 1 equals returns 3 things. And then immediately after that, in square brackets, 0 to get only the first of the 3 things that it's returning. If you do that, then the other 2 things that it returns, they'll be created when the function runs. But because you don't capture them in a variable, they'll immediately disappear again from the memory of the program. So it will use up that memory while the function's running. But then as soon as you capture just that first part of the output and discard the rest, that part of the memory of your program will be cleared. And so you don't need to worry about kind of building up all of this additional like byproducts that you're not actually interested in using in your program. All right, I hope that answered that question. Back to the Etherpad. There's questions 2 and 3 here. I'll try and answer these quite quickly. Someone was talking about how they need to work with data frames and arrays. They need to learn how to access from files and be able to transform them and so on. And so in terms of array data, we've been working with that bit already. The kinds of operations that we've been performing on them have been mostly like summarizing, calculating means and minimums and maximums and stuff like that. But if we look at one of these data, I guess I've still got a data variable, and type dot, and press tab like I was doing with the list yesterday. What we see here is a list of all of the methods and things that are carried around with these NumPy arrays. You can take a look through here and find that there are a bunch of kind of standard operations that you would want to perform on arrays of data. And so T here, that's the what's it called? Transverse or something of the array, for example. So it makes all the rows columns and all the columns rows. And so you can look at the methods that come along with those array objects as one of the ways to learn more about the kinds of transformations that you can do. Again, like I said before, I recommend checking out the NumPy documentation as well to learn more about how to work with those kinds of arrays of data. But then the other thing that I can really recommend, and this is to the person who was asking about working with data sets that contain multiple variables and then how to call those variables by name. This might not work for you, but perhaps it does because you've installed Anaconda. There's this other library called Pandas, which is specifically designed for working with data frames of data. So still tabular data, but where you've got multiple columns of different types of data rather than what we've had so far, which has been an array of kind of the same kinds of values in 2 dimensions. And Pandas provides a whole bunch of functionality. And so, for example, we can, let's call this DF. We can do load CSV and load, and I just downloaded some more data to demonstrate this with. So I've got Gapminder data, Gapminder all.csv, and run this. I'm afraid you won't have this. Okay, that's interesting. What did I do? It's read CSV, I think. Yeah, there we go. Read CSV. Cool. And so running this read CSV function from pandas creates a data frame object. And let's have a look at what's in that data frame object. So I run this in Jupyter, and you see already you get this big long data frame. And so we've got a bunch of rows and a bunch of columns that contain different kinds of things. We've got continent and country that describe the continent and the country, but then we've got GDP per capita for each of those countries in 1952, and so these are numeric values. And then we've got population values for these different years as well later on. And so this is a pretty big data frame, I think. So yeah, 142 rows and 38 columns, I think. And I don't have time, of course, because we've just hit the top of the hour. I don't have time to teach you a bunch of things that you can do with pandas, I'm afraid. But what I can highly recommend is that you check out the documentation for pandas. Software Carpentry also has another lesson all about working with pandas with this kind of Gapminder data set that I've just loaded in, which I'll put into the Etherpad as well, the link to, but I've just put the link in the chat. That covers some of the same kinds of basics of Python programming that we've talked about today, but it also looks in much more detail at pandas and working with data frames and performing operations on the different columns, depending on what kind of data they have in them and that kind of thing. So I think that's a good next step that you can take if you're interested in learning that stuff more with Python. I've experience in using Stata for data management analysis and plotting. Are there any resources that can make a transition to do the same stuff with Python? I don't know, I'm afraid. I don't know the answer to that question. I think the Carpentries Incubator includes a Python for Business lesson, which might answer that question, but I'm not really familiar with the contents of the lesson enough to be able to say for certain, but I'll provide a link anyway in the chat in case that turns out to be useful for you as well. All right, we're out of time, 2 minutes over. I'm sorry for keeping you here late. Thanks again for being here. Tomorrow we will switch to a completely different lesson. We're going to be talking about version control and keeping track of changes in your projects using Git and GitHub. That's my favorite lesson to teach. I'm really looking forward to doing it. So thanks again for being here. Thanks for asking questions and providing feedback and so on. And yeah, I'm looking forward to coming back tomorrow and teaching you some more then. Cheers.